Alright, so here's a Jeb Door, and it's really just a bunch of simple components all put together. For this build, I was using the power source externally. It's using some electromagnets, and the electromagnets end up using a lot of current. It hits almost 2 amps, and that's if the microservers get stuck. It consumes a lot more current. In the on state, you can see it draws around 1 amp, and that'd be 1000 milliamps. AAA's I'm using are around 1000 milliamp hours, so I didn't want to force the batteries too much. I'm gonna start from the top and go to the bottom, starting with these two end caps. They're both the same circuit, they just have an LED with a resistor. And so when the lever flips on, it sends current through the left, through the LED, through the resistor, and down to ground. Here's the right side, it's the same. You can see the same circuit. These two corner blocks divert the signal into 90 degrees and also down into these pistons. And so if I pop these off, there's pins here that go down into these set of pistons and send the signal down. I also have the power going into this block here, as well as the ground. So here's the right end cap. It's the same redstone dust LED circuit. There's an input of the yellow and output of the blue. Over here on the right, there's a jumper from the input and down into the input of the piston block here where the pins are. Here it has power input, ground, and a signal. So for the two repeater blocks, nothing has changed. Just for the output, the ground is on the bottom instead of up here. The only thing on the top pins is the output and also the input. Here in the middle is the main circuit for getting the middle pistons to extend, and it activates the pistons without any physical contact. First, I thought about making contact pads using this copper foil tape. The copper is really finicky, so I didn't want to mess around with that. I wanted a secure connection somehow. In order to get the secure connection, I'm using electromagnets that I've made. So on the top is the same LED redstone dust circuit, but underneath are the electromagnets. Also on the bottom is just passing power straight through the blocks off of the bottom set of pins. Here's the electromagnet, and on the top is a Schottky diode. When the electromagnet shuts off and the magnetic field starts to collapse, that collapsing of the magnetic field induces a voltage. The voltage spike can reset the microcontrollers, and so you can see this happening where one piston would fire off faster than the other, even though there's a set delay within the repeater. After I added the flyback diodes to both sets of electromagnets, the problem went away. The magnetic field isn't too strong created, it's just enough to activate the bottom pistons. After a while, the coils do start to heat up a little bit, so I recommend using a smaller gauge wire and adding more turns in order to reduce the amount of amperage running through. On the outside, it's using the redesigned lever. It's just connecting the positive voltage out into all these circuits. So now for the middle set of pistons, this is using the alternate design where the extra block is added in the front to reduce the amount of blocks needed. In order to attach the middle blocks to the outer blocks, I used aluminum foil tape just because it had the best adhesive. A better solution would probably just be duct tape. The bottom piston is holding the battery pack here on the bottom, and the top piston holds the circuit as well as the micro servo. Here on the left, I hot glued the wire just so it wouldn't move around inside, but would allow enough slack for if it's extended all the way, it's able to pull back as much as needed. When it retracts, the wire is set up in a way so that it doesn't interfere with the closing. Here's a microcontroller circuit board, and it's using the Atmega 328. The micro servo wires just hook off, as well as the power wires. And in order to get the signal from the electromagnet, I'm using a Hall effect sensor. And the Hall effect sensor receives the magnetic field. It allows a path for this right lead to go down to ground. This changes the state of this yellow wire from high to low and gets red. This little module also just pops off. And so now it's just a little custom Atmega 328 with a reset pin here. I also used hot glue in order to get the Hall effect sensor to stick to the top, and so it wouldn't sag down too low where it wouldn't read the electromagnet. The right side middle pistons would activate first just because of the placement of the electromagnet and the Hall effect sensor. So basically the right side would move, continue moving, and around here it would activate, while the other side would move all up until it would be fully pushed up against the other piston, and then it would activate. So sometimes the middle pistons would be out of sync from each other. So now finally for the side pistons, there are 2 pairs of stacked pistons. And for the right side, I ended up taping it with aluminum foil tape in order for everything to stay straight. On the left side, it didn't work too well having it taped. Sometimes it would get stuck. An issue I came across with this design is that I had to sand here in the middle where these parts meet. So along with polishing up the shaft, I recommend sanding down where these meet, and that should help with extending. There's only one micro servo with one microcontroller inside this piston, and so through these connections made here, it's able to pull out the other side set. If you add another micro servo, you'd have less issues with the piston actually pushing out. You can add another micro servo to the other side to make it more powerful. You could also daisy chain the signal so that you only use one microcontroller for 2 micro servos, or you can use one microcontroller to use 4 micro servos. On the bottom, it does have some foil tape in order to hold them down. The bottom tape also connects both together, so it doesn't flex all that much. You can see how the right side doesn't have a micro servo, and then on the left is a micro servo. Something really weird that happened is that the left circuit just stopped working, and so you can see turning it on and off, the left side won't move at all. Sometimes it would get stuck on position, like right now. Other times it would just shut off completely. I'm not sure if it's the servo or if it's the microcontroller, but in order to get it to work again, I just reset the power supply. So now you can see it's working. And so it usually end up not working anymore after a couple of goes. Other times it would continuously run. So might be something with the connections, it might just be something internally. So that's pretty much it. If you guys have any questions, as always, let me know, and thank you for watching.